Day 2 of problem solving with polynomial equations, aka word problems. And if you have any hope of doing these, and you don't want to be lost and, we'll say, hopeless, you should be kind of well versed in the homework from before. So we're just going to kind of continue, same directions as before, starting with a rectangle, 3 times as long as it is wide. So if I draw just a simple rectangle, and if it's 3 times as long as it is wide, probably logical to say W and 3W. Then we've done problems like this before where we create a second rectangle, and we say if its length is decreased by 4, so 3W minus 4, and its width is increased by 2, W plus 2, the new rectangle formed has an area of 112. So my whole equation is going to be taken from this new rectangle, and I'm going to say that the area of this one is 112. So 3W minus 4 times 2W plus 2 equals 112. Let's multiply that out. 3W squared, that'd be plus 6 minus 4, so plus 2W, then minus 8 equals 112. Let's subtract 112 from both sides. 3W squared plus 2W minus, this is going to be 104, is equal to 0. Now we have a little bit of a factoring challenge, so let's split this into parentheses and just kind of set this up. 3W and W. 104 is the same as 52 and 2. 52 is 26 and 2, so that's 26 and 4. If I multiply the 4 times 3, I get 12. That's not close enough. So let's cut that in half again. 13 and 8. If I multiply the 8 times 3, I get 24. That's not going to do it. Let's try the 13 times 3. 13 times 3 is going to be 39. 39 and 8. That won't do it. So then I reevaluate my original thing where I realized that if I subtract 112 from 8, I get 120. I'm going to leave this mistake in here since only a few of you are watching it, and it's worth noting that if you do have something that you can't factor and you've tried all the factoring methods, go back and check your original equations and make sure that you did set that up correctly. So here's where my mistake was. It's 120 we need to factor. So let's try that. 120 is 60 and 2, 30 and divided by 2, 30 and 4, 15 and 8. If I take a 3 out and make that 24 and 5, 24 and 5 won't do it because 5 times 3 is so let's try to get a 2 in there. Let's make that 10 and 12. That won't work. Let's make that 20 and 6. 6 times 3 is 18. There we go. 6 times 3 is 18. 20. And then I get a plus 20 and a minus 6. That will get me to 2 in the middle. So I'm highlighting this because you're not going to always get it right away when factoring some of these with word problems. And the factoring may be one of the bigger challenges, but you just keep trying. 120 has a lot of factors and a lot of ways it can split up, and you have to check that when you multiply one of them by 3, do you get 2 apart. So I get W equals 6. Remember, W is not going to be equal to negative 20 thirds because it's a side length. But I also want to check that when I plug 6 in to everything, I don't get any negative numbers. So that's a good check. And finally, the question asks for the dimensions of the original rectangle. So I'm going to say the original rectangle is, if I plug it back in, 6 by 18, I believe it's centimeters. Okay. Let's move on to a swimming pool, rectangular swimming pool, with its length twice as long as its width. So we have a width and a 2W. And then it's to be surrounded by a cement walk 4 feet wide. So I'm going to surround this by a cement walk that is 4 feet wide. Now it says it's 4 feet wide. It's talking about this distance here. That's 4 feet. That's 4 feet. This is 4 feet. And this is 4 feet. So when I look at the outer dimensions now, my kind of entire thing, like meaning the whole picture, the swimming pool plus the walk, my width has now increased not by 4, it's increased by 8. So people get confused and say, well, wait a minute, there's a W right next to a 4. No, actually, if I look at the length, this is W, but then this here is 4, and this here is 4. So the whole width happening, this width, almost got that. Let's try that one more time. Nope. I'm trying to just grab the highlights. There we go. If I slide the highlights over, that is W plus 8. By the same logic, my new length right here is the 2W, but also plus 8. And then it says the total area is 2880 square feet. So total area is going to be the outer length times the outer width equals 2880. You can actually at this point factor out a 2 from here if you'd like. If I pull the 2 out and divide the 2 to the other side, I get W plus 4 times W plus 8 is equal to 1440. That way my numbers are just smaller, and then I can FOIL this. W squared plus 32W, oh, not plus 32W, plus 12W plus 32 is equal to 1440, or W squared plus 12W minus 1408 equals 0. So we now have to split up 1408 and just do our best to kind of break this up into factors that are somewhat close to each other, 12 apart. So 1408, if I cut that in, let's divide that by 4. Actually, I'm just going to divide it by 2 twice. So it goes 2, 704, 4, 352. 352 is also divisible by 2. So if I divide that by 2 and multiply the other one by 2, I get 1, 7, 6. That can be divided by 2, so I'm going to get 16, and I get 16 and 88. 16 to 88, I can take that by 2, so 32 and 44. There we go, 32 and 44 are 12 apart, so I get W plus 44 and W minus 32 equals 0. And that means that W would have to be equal to 32. The question asks for the dimensions of the pool. So the pool is this thing. See little aqua waves. So it's not the outer dimensions, it's just the inner ones. So the pool is 32 by 64 feet. Okay. Moving on. Farmer plans to use 25 meters of fencing to enclose a rectangular pen that has an area of 63 meters squared. Only 3 sides of the pen need fencing because part of the existing wall is being used for one of the longer sides. So if I look at it vertically, here's an existing wall, and then here's my pen that I'm kind of drawing around. And if I know that the area is going to be 63 meters squared, and I don't have anything else listed, so let's just put W's for widths. I don't want to really say L here, although I can. Let's actually do that. Let's just put an L, because if you want to set up a system, you can say LW equals 63, but then also 2W's plus L equals 25. Now, how do I know that second equation? Well, because I'm going to do that in aqua, actually. Because that's the fencing. 2W plus L is not the perimeter, it's the amount of fencing we have, because the fencing's on 3 sides. So since the fencing's on 3 sides, I only want to add up the length once. It says part of an existing wall is used for one of the longer sides. Now we just need to solve this system, and like before, I'm just going to solve for one of the variables. I'm going to solve for L, because if I solve for W, I'm going to have to divide by 2. So I get L is equal to 25 minus 2W. Plug that in, and we get 25 minus 2W times another W is equal to 63. That gives me negative 2W squared plus 25W equals 63, or 2W squared minus 25W plus 63 is equal to 0. And then we just need to do the splits again. 2w, w. We can start with 9 and 7. So 7 times 2 is 14. 14 and 9. It's supposed to be same sign, so minus minus. 14 plus 9 is not 25. Let's try to swap those. 9 times 2 is 18. 18 plus 7 is 25. So you get w is equal to 7 halves, or w is equal to 9. Okay, so let's come back up here. If w is equal to 9, I want to solve for L in both cases to figure out which of these it actually is. So L is equal to 25 minus 2 times w. So if 25 minus 2 times 9, if w is 9, L is 7. Well, that would make the length shorter than the width. So that one's out and that one's out. Then I'm going to solve for the other one, 25 minus 2 times 7 halves. That gives me 18. So that puts the length at 18 and the width at 7 halves. And that should be correct. So I can say, we'll just say the dimensions are 3.5 meters by 18 meters. Okay. And then finally, a poster. Dimensions are 25 by 30. So I have a poster that is 25 here and 30 here. And it's surrounded by a border of uniform width. When we say uniform, we mean same. It's the same width. That means the thickness of this. This is just like the swimming pool problem from before. And without even doing anything, I'm going to kind of say let w equal the width of the frame in inches. And I know that this is going to be 25 plus 2w, and this is going to be 30 plus 2w. Then it says the area of the border is 172 square inches. Well, border area is equal to the whole area minus the picture. So the whole area is 25 plus 2w times 30 plus 2w. And then we're going to subtract the picture area, which is 25 times 30, and that's the border area, and that's going to be equal to 174 according to the problem. So let's go ahead and multiply. For 4w squared plus 50 plus 60, so plus 110w, plus 25 times 30 is 25 times 3, 750, minus 750 equals 174. So then I get 4w squared plus 110w minus 174 is equal to 0. Then we can cut everything by a 2. 2w squared plus 52w minus, this would be 87, is equal to 0. Let's break this up. 2w and w. 87 is divisible by 3. If I take a 3 into it, I get 29. So 3 and 29. Well, if I multiply the 29 times 2, we're going to get 58. Let's see, 29 times 2, 58. That won't get me to 52. Let me pause and see what I did wrong for a second. I see what I did wrong. Half of 110 is not 52, it's 55, and my factoring is actually pretty fine. So if I go plus there, minus there, that will get me the 55. And I get w is equal to 3 halves, because w can't be negative 29. And it wants the width of the uniform border, so we say the width is 1.5, let's see, what was the units? 1.5 inches. And that's it.